Hello friends, I am Ritesh sir. In the last video I taught you the basic formula of the chapter called time and distance. Yes, I know it's a scary chapter, but I will try to simplify things so that your fear can be eliminated. Now, in case you have not watched the previous video, please do watch it so that you get a basic hang of the formula. Now I will teach you relative speed. Now it sounds very scary, relative speed. However, it is not. And you will come to know why the sums involving those long and monstrous trains are not that challenging. So let's divide the thing into two chief cases. The first case is, as you can see, these are two trains. Let's say that this is the first train AB and this is the second train CD. The arrow sign shows the direction towards which it is moving. So AB is moving in this direction and CD is moving in this direction. So basically, as it's given in the books, the trains are moving in opposite directions towards each other. Now let us note their respective speeds. AB is moving at a speed of 100 km per hour. CD is moving at a speed of 50 km per hour. And the distance between these two trains is 900 kilometer. Yes, 900 colossal kilometer. Now, the question which is asked is, in how much time will the two trains meet? Or after how many hours will the two trains meet each other or cross each other? Okay. It's not that difficult, though it sounds very daunting, it sounds like it's a big thing how to calculate all those stuff. But wait, it's not so tough when I am teaching. So it's given here that what I have written is RS. Now RS stands for relative speed. As you can see, I am short of space. So I have written the short form. When two trains are moving towards each other, now think about it. In every 1 hour, this train is moving 100 kilometers in this direction. At that same 1 hour, this train is covering 50 kilometers from this direction. In short, the two trains together are covering 150 kilometers in one single hour, right? This is moving 100 kilometers eastward and this train is moving 50 kilometers westward. So in 1 hour, simultaneously, together, the two trains are reducing the distance of 150 kilometers between each other. Is that right? Which means their relative speed or combined speed is 100 plus 50, that is 150 kilometer per hour. Therefore, if you need to find the time at which they will cross each other, the time taken, I'm not writing, the time taken will be the total distance, which is 900 km, divided by the relative speed, which is 150 km per hour. So the required time taken is 900 by 150, which is 6. So the answer is 6 and 6 hours. Yes, to calculate time, you use the unit of hours. Again, watch my previous video in case you have not. So the total time taken is 6 hours, which means if the two trains start off at say 10 a.m., then they will meet exactly 6 hours later, which is at 4 p.m. Alright? Now we move to case 2. Now imagine we have another long and monstrous train, AB, the same train actually, and you have CD. Again the same train. However, this time the train CD chooses to move in the other direction. So it is not moving in this direction, but it's moving in this direction. So basically, both the trains are moving in the same direction. If this is east, then both the trains are moving eastward. Again, the question that arises is that will this train be able to cross or meet this train? Now note that will happen only if the speed of this train is more than the speed of this train. In this figure, you can find out that the speed of train AB is 100 and the speed of train CD is 50. It means that eventually this train will cross and surpass the other train. Alright? But after how many hours? That's the big question. So again, for your convenience, I have kept the figures same. So let's say the distance between these two trains is 900 kilometer at the outset. To begin with, after 1 hour, this train will have moved 100 kilometers in this direction. But at that same 1 hour, this train would have further moved 50 kilometers in this direction. So it is moving away and it is moving towards. It is moving away and it is moving towards. But note that this train is covering 100 kilometers in every 1 hour. This train is covering only 50 kilometers in 1 hour. So effectively, this train is covering 50 kilometers extra, which means their relative speed or combined speed is 100 minus 50. It covers 100 kilometers, but it increases 50 kilometers. So in every 1 hour, this train is trying to shorten the distance between them by 100 kilometers. But at that same 1 hour, this train is furthering or lengthening that distance by 50 kilometers. But because 100 is more than 50, so in every 1 hour, the distance between them is getting shortened by 100 minus 50, which is 50 kilometer. Which means that in every 1 hour, the distance between them is decreasing by 50 kilometer. So in 1 hour, after 1 hour, the distance between them will become 850. After 1 hour, after further 1 hour, the distance between them will become 800. After 3 hours, it will become 750. After 4 hours, it will become 700. So eventually it will become 0. When it becomes 0, the two trains will coincide, which means the two trains will meet each other. So again, the formula is, you have to find time, you are finding time, so the formula is distance by speed. In this case, the formula is distance by relative speed, which means distance 900 kilometer divided by relative speed, which is 50. So the answer will be 900 by 50 hours, which is 18 hours. Alright. So in 18 hours, train AB will match up to train CD and it will coincide with it, and which means the two trains will meet after 18 hours. And beyond that, train AB will go past train CD. Alright. Okay. If you have any questions, please post in the comment section, and if you liked my video, then please subscribe, please like, and I hope to see you soon again. Thanks.